A water tank can be filled in 7 minutes and emptied in 9 minutes. If the drain is accidentally left open when the tank is being filled, how long does it take to fill the tank? So this is the second word problem. And the way to solve these kind of word problem is exactly the same. So we're going to use the universal formula W equals R times T. And then we're going to create a table to summarize the different situations that's described in this problem. We have filling and emptying. These are the two different situations. And of course, the drain is left open, so that means filling and emptying happening at the same time. So those are the three situations that we should have. So you have fill, you have empty, and then you have fill plus empty. So that fill referring to the situation that you're only filling the tank, and then the empty representing the situation that you're only emptying the tank. And then the last situation, fill plus empty, is the question. You are filling and emptying at the same time, but apparently according to the numbers given by the problem, you're eventually going to be able to fill the tank even with the drain accidentally left open. So let's figure out each situation. The tank can be filled in 7 minutes. You're filling a tank, so your work will be 1. The time is 7 minutes. So according to the calculation, 1 equals 1 over 7 times 7. So that would be the rate of filling, 1 over 7. Next, emptying. You're emptying the water tank. So the emptying the amount of work, some people might say it's still 1. I would say, yeah, kind of true, right? You're emptying the tank. It's just 1 tank. But the only problem is this time you are emptying the tank instead of you're removing water from the tank instead of adding water to the tank. So I would say the amount of work would be negative. So -1, simply because you are removing water instead of adding water. And then the amount of time, it says it's 9 minutes. Therefore, if you calculate this, you will get that the rate of emptying is actually -1 over 9. So this is actually something that you need to be careful about. Emptying, you are removing the water, so your rate is actually negative. Even though when you're doing that, the rate is positive, but in terms of adding or removing water, since you're removing water, we will say the rate is negative in that particular sense. So it's -1 over 9. Next, you are filling the tank, but with the drain left open. So fill plus empty. You are filling the tank. That means you're adding water. So your total amount of work once you are done will be 1. It's positive. The rate, just like before, when two people work together, the combined rate is simply the sum of those previous situations. So in this case, we are doing 1 over 7 plus -1 over 9, or it's simply 1 over 7 minus 1 over 9. And then you could see that the rate of filling is actually greater than the rate of emptying. That's why you're able to fill the water tank. So if you calculate this, 1 over 7 minus 1 over 9, it's going to give you 2 over 63. 2 over 63. And some people might wonder how I calculate that. So let's actually do that. The least common denominator is 63 for both of them. And the first, I multiply both the top and bottom by 9. So that's 9 over 63. The second fraction, I multiply both the top and bottom by 7. So it's 7 over 63. And that's why I got 2 over 63. And then you multiply that by t, which is what we need to find. So you have an equation, 1 equals 2 over 63 times t. We just need to solve for t. Inverse operation, we will first multiply both sides by 63 to get rid of that denominator. On the left-hand side, it's 63. On the right-hand side, it's 2 times t. And then we divide both sides by coefficient of t, which is 2. And then we obtain 31.5 equals t. So you could answer that it will take 31.5 minutes to fill the tank, which makes sense because you are draining the tank at the same time, so it should take longer to fill the tank. And then you could box that. And of course, there are other ways to solve this problem, but I'm just trying to show you a universal way to solve any kind of word problem that you might encounter on your final exam. And good luck on your final exam.